Welcome to the first lecture for Math 1314. I am Professor Michael Bailey at Brookhaven campus, which is part of Dallas College. This class is college algebra. The code is Math 1314, and we're going to begin with Chapter 1, looking at graphs, functions, and models. In the first section of Chapter 1, most of this will probably be review, with some extra formulas in there that you might remember, or they might possibly be new. We're going to learn how to plot points on a graph. We're going to identify what an ordered pair is and figure out if it is a solution to an equation. We're going to learn how to find the x and y intercepts of an equation on a graph. We're going to learn how to graph equations. And we're also going to learn how to find the distance between 2 points using the Pythagorean's theorem. And we're also going to find the midpoint of a segment, or the midpoint distance between any 2 points. The Cartesian coordinate system, everyone knows this, and this is actually one of the most powerful mathematical tools. When you think about, when you look at graphs in paper and bar graphs, rectangular graphs, a lot of times you can interpret what's happening almost instantaneously with a visual representation of data. For example, if you saw a bar graph that was indicating profits, and you saw rectangles, stacked rectangles going higher as you move from left to right, you would know that that company is doing better because its profits are increasing. And you would know that almost instantaneously by the labels on the graph and just by the size of the rectangles. So this system is named after René Descartes, a French philosopher and mathematician. And it's a really powerful thing to be able to visualize numbers, to visualize quantities, to visualize elements, etc. And so the basic of that, the foundation of that, is this Cartesian coordinate system that you know, I'm sure. And that's just simply the XY graph. The official name is the Cartesian system. And these Roman numerals, we label each quadrant or quarter. In the upper right, we start with quadrant 1, and then we go counterclockwise. So in quadrant 1, x is positive and y is positive. In quadrant 2, notice that x is now negative since we're on the left side of the y-axis, and y is positive. Keep going counterclockwise. We see in quadrant 3 that both x and y are negative. X over here, left of the y-axis, and y below the x-axis. Okay, and then in quadrant 4, x again is positive because we're right of the y-axis, and y is negative because it's below the x-axis. When we're trying to plot a point is identified as an ordered pair. This exactly is an ordered pair, parenthesis, an x value, comma, a y value in parenthesis, and this is what we call an ordered pair. Now, you've done a lot of these probably, and it's very easy to make mistakes on something that we're very confident with because we go too fast. So often what happens is that we just juxtapose these values. We go over y and then up x, instead of what we should do is go left or right, the x value, and then up or down the y value, again, depending left or right, up and down, whether x and y are positive and or negative. So to graph a point, or plot a point, the first coordinate tells us to move left or right, that's the x value, and the second coordinate, the y value, tells us to move up or down. So here, since we have a negative 3 for x and a positive 5 for y, we're going to move 3 units to the left. You can see this, hopefully you can see the color there. 1, 2, 3 units to the left because x was negative. And then we're going to move 5 units up. 1, 2, 3, 4, 5. Then we're just going to draw our point, and it's very important that we label our point with the ordered pair, comma, negative 3, parenthesis, negative 3, comma, 5. Plotting points is very simple, but take your time, especially on a test, because you don't want to get points off because you made an error plotting, supposing x and y. We say that equations that have two variables, x and y, have solutions that are ordered pairs. And what that means is when for example, we might put a value in here of 2, 4, parenthesis, x equals 2, or parenthesis 2, comma 4. And when we would plug in those values, if it is true, then that is a solution of this equation. That ordered pair is a solution, okay? If an ordered pair or a point on a graph is a solution, that means that this line will actually go through that point. If we put another value in here, for example, if we put 0 and 8, which would not satisfy this equation, then 0, 8 is indeed a point on the graph, but the line will not go through it. So when the ordered pair is substituted into the equation, if it is a solution, the result is a true equation. We would get 18 on the left to equal the 18 on the right. It has to be a solution of the equation in order to receive a true statement, okay? So x, y values that you plug into this equation that do not make it correct are not solutions. Only x, y values, ordered pairs, that when you plug them in, make this true, are solutions of the equation, okay? So let's look at a couple. Determine whether the ordered pair -5, 7 is a solution of 2x plus 3y equals 18. So what we're going to do here is plug in x equals -5. So where there's an x, we're going to plug in -5. And where there's a y, we're going to plug in 7. Okay? And now the question mark there is just saying, does this actually equal 18 or not? Okay? So 2 times -5 is -10. 3 times 7 is 21. -10 plus 21 is 11. Does 11 equal 18? No. So this is false. So what this means is this ordered pair is not a solution of this equation. Let's try another. Determine whether the pair 3, 4 is a solution of 2x plus 3y equals 18. Again, we're going to plug in 3 for x and 4 for y. This is just direct substitution. We plugged in 3 for x and 4 for y. And now we're going to do the math on the left to see if indeed this is equal or not. I don't know why they put equal there, and why they didn't write it down the whole time. So again, when we do the multiplication and then do the addition, we do see that 18 equals 18. So indeed, this is true. And that means at that point, that ordered pair is indeed a solution. So when we graph an equation, what we're looking for is all of those, well, maybe not all of them, but several ordered pairs that we can then plot on a graph on the Cartesian coordinate system and then connect the dots. Hey, see, math is pretty basic. Remember that game, the dots, when you were little? Some of the easier ways to do this is if we find what are called intercepts. And intercepts, like an intercept of a football, is where it crosses, right? You catch it instead of someone else. This is where we cross the x-axis. And notice that we will only cross the x-axis if the y value is 0, because everywhere along the x-axis, the y value is 0, because that goes through the y equals 0 value. Okay? So to find the x-intercept of this equation, 2x plus 3y equals 0, and again, this is a place where you got to be careful, because you think x-intercept, oh, okay, well, let me make x 0. No. For intercepts, you make the other variable 0. So to find an x-intercept, we let y equal 0. To find the y, we'll do the opposite. So we plug in y equals 0. So we have 3 times 0. We get 2x equals 18. Divide both sides by 2, and we get x equals 9. Okay? Now, the x-intercept is a point. So if I say, what is the x-intercept, and you said x equals 9, that's not really correct. The x-intercept is 9, 0. It is an ordered pair. Okay, so you should write that the x-intercept is 9, 0. It is a point. Yes, indeed, the graph intercepts the x-axis at 9, but the x-intercept is a point, and it should be written as an pair. Similarly with the y-intercept, This is where the graph crosses the y-axis, and of course, x equals 0 for every point along the y-axis, and because the y-axis goes through x equals 0. So we're just going to do the opposite. We have this equation. Now we're going to substitute x equals 0. So we're going to plug in a 0 for x here, and we're going to get 2 times 0 plus 3y equals 18. Divide both sides by 3, and we get y equals 6. So again, the x-intercept and the y-intercept are points, so we need to record them as points. The y-intercept is not y equals 6. The y-intercept is parentheses 0, comma 6 parentheses. So we found 2 points. It's generally a good idea, especially with a linear equation, to find a third point, okay? So if we want to find another point, we just pick a value for x or y. So in this case, we've picked x equals 3, plug it in for x, and then we figure out what y is. We could do the exact same thing with y. We could make y equal 2, plug that in, and then figure out x. It's your choice when you're plotting equations to pick which variable and what value you want to pick. All right? So if we pick that x is 3, then we plug in 3. 2 times 3 plus 3y equals 18. We get 6 plus 3y equals 18. We subtract 6 from both sides, and we get 3y equals 12. We divide both sides by 3, and we get y equals 4. So another solution to this equation is 3, 4. Now we have 3 points to plot. Now why do we do that? Because this is a linear equation. If I put any 2 points on a graph, it will always make a straight line. And so I may have calculated one of those points inaccurately and not known it because I didn't calculate a third point. If you have a linear equation and when you plot it, you have a triangle, you have done something wrong. A linear equation is a straight line, not a curve, not a triangle, etc. So plot 3 points, and that is a check of your work. We list the points, can also be listed in a table. There's the ordered pair, 0, 6, x, y. We plot them on the graph. Remember, go left or right x values, and then up or down y values. So for 0, 6, we start at 0. We go 0 left or 0 right, because that's the x value. And then up 6, because it's positive 6 is y. For 9, 0, we're at the 0. We go to the right 9, because it's positive 9. And we don't go up or down because we go 0 units up or down. And the last one is 3, 4. We start at the origin. We go 3 to the right because it's a positive 3. And then we go up 4 because it's a positive 4. And we can see that these are all in a line. If we had calculated any one of these wrong, for example, let's say we had a point here at 8, 4. Then notice what we would have is some kind of weird triangle, not a straight line. And that is, again, why we plot 3 points for linear equations. It's just kind of a built-in check that makes it pretty easy to build and check it. What happens if we have a higher ordered equation? How do we graph this? Well, you have your graphing calculators, and I strongly suggest that you go into the Tools for Success in your MyLab Math and look under the graphing calculator tutorial for the TI-84 or TI-83. It's a great tutorial. It has a virtual calculator in there. It walks you through step by step. It gives you examples and problems. And if you've never used one of these, it's a great way to go. Okay? So you can use your calculator to graph these, but the way we would do this step by step analytically is we would figure out a table of values. And here we would just pick some x values, and then we would calculate the y values by plugging them in. And we could do this the opposite way. Much more difficult though in this problem if we figure out the y, if we plug in a y value and then try to figure out x, because we have a quadratic equation. Then we simply plot some of these points and connect the dots. Okay? We're going to look at more about these quadratic equations and functions and plot all of them. We're almost done our first lecture. The distance formula gives us the distance between any 2 points. So we have this point here, x1, y1, point 1, and we have point 2. Now notice what this is Pythagorean's theorem. the square root, or excuse me, the square of the hypotenuse is equal to the sum of the squares of both sides. Well, notice the length of this side, this up and down side, is the difference between the y values. If this was y equals 2 and this was y equals 4, then this would be 2 units high. So the distance, the length of a side, is simply y2 minus y1. And it doesn't matter the order, you see the absolute value signs there. The distance along the horizontal distance here is the distance between the two x values. So if we're trying to find this distance, now we got to be careful. We don't want the distance squared. We want the distance, so we take the square root of the length of this side squared, x2 minus x1 squared, plus the height squared, y2 minus y1 squared, and then calculate that. It's a very simple formula to remember if you think about the Pythagorean theorem, but it's a good formula to have in your pocket. A good test thing to do, since you're not allowed to have notes on any of your tests, is to, when you get into the testing center, is just take a blank sheet of paper and maybe write down the formulas that are key for each section, or the section you're testing on, excuse me. So if we're going to find the points here, we're first going to take the difference between the x values, 3 minus 2. Always put that in parentheses when you have negatives, so it doesn't get you confused. Minus a minus becomes plus, okay? Now here's where we make a mistake often, okay? A lot of times if this number is bigger than this number, etc., we don't put them in the same order. So since 3 is the first digit, -6 has to be the first digit too. Since this x is the first digit, then this y has to be the first digit too. So we have 3 minus a -2, -6 minus 2. Okay, this is another place where we make simple errors. Sometimes we get confused with a negative minus. Would that be -4? Would that be -8? And I'll tell you what I do. I always think about my checking account. If my balance in my checking account is -6 and I spend $2 more, I don't go to -4. I might like that, but that's not how it happens. So think about money and then you'll know the answer. Okay, so we just do the calculation here. You have a calculator that you're allowed to use throughout the entire course. And here we get the approximate value of 9.4 units for this distance. Okay, and that's just a visual representation of the distance between those 2 points. Okay. To find the midpoint, this is the point in the very middle of a segment. This is very simple. What we're going to do here is add up the x values and divide by 2, and that's our new coordinate of the x value. Add up the y values, divide by 2, and that is our new coordinate of the y value. So here we're not trying to find the half the distance. We could just do the formula we did before and divide by 2. Here we're trying to actually find the midpoint, another point, another xy. Okay, so again, remember here we just sum the x's, divide by 2, sum the y's, and divide by 2. And this one's pretty intuitive. Most people can remember this formula because it's the kind of formula you would make up, right? If I'm trying to find the halfway point, I divide by 2. Okay, and so here I have the values, and you can see the coordinates on a graph. I believe that's the end of our lecture.